Kindly subscribe to the channel for more updates.
Hello and welcome to our series of tutorials on various content in relation to the teacher's licensure examination. In today's video, we shall be looking at multiples, the least common multiple, and the applications of the LCM under the subject numeracy. Before we start with any concept, let us look at a piece of motivation. Luke exercises every 7 days and John every 6 days. Luke and John both exercise today. After how many days will they exercise together? By the end of this lesson, you should be able to solve questions like this. For now, some of you might be having issues answering or solving this particular problem. But trust me, by the close of this video, you'll be able to answer similar questions and even more difficult ones. Now let's start with our first concept. What is a multiple? A multiple of a number is a number gotten by multiplying it by a counting number. Now, multiples of 2, for instance, can be gotten by multiplying 1 by 2, and then the first one we have is 2. Multiplying 2 by 2, then we'll have 4. Multiplying 3 by 2, now we have 6. Multiplying 4 by 2, and we'll have 8. Thus, the multiples of 2 can also be continued to be. Thus, the multiples of 2 can now be stated as 2, 4, 6, 8, 12. And as you continue multiplying, the more you get. Multiples of 5 too can also be listed as 5. Then, when you multiply 5 by 2, we have 10. 5 by 3, we have 15. 5 by 4, we have 20. And so on and so forth. The multiples of 5 will also include 6, 12, 18, 24, 30, and so on and so forth as you multiply them using consecutive counting numbers. The multiples of 7 too may also include 7, 14, 21, 28, 35, 42, and so on and so forth. Now let's look at the lowest common multiples, LCM. The least common multiple of a given set of numbers is the smallest number present in the set of their individual multiples. In other words, it is the smallest number divisible by those given set of numbers. For instance, if the multiples of 8 is simply equal to 8, 16, 24, 32, 40, 48, 56, and so on and so forth, forming a set, and the multiples of 6 equal to the set 6, 12, 18, 24, 30, 36, 42, 48, 54, and so on and so forth, then the LCM of 3 and 5 is 24, since it is present in the multiples of 8 and of course the multiples of 6. In other words, 24 is the smallest number divisible by both 8 and 6. Now, can you find the LCM of 120, 150, and 180? Well, this is getting pretty ugly, right? No big deal. Now, the method I'm going to introduce to you is going to make it easier for you in finding the multiples of large values like those you see on the screen. Now, let's go ahead. Now, let's look at finding the LCM using continuous division. Here, you continuously divide the given numbers with a prime number divisible to at least one of the numbers until the final answer for all is 1. Now, let's look at this example. Find the LCM of 6 and 8. Do you quite remember that we had the LCM for 6 and 8 to be 24 in our previous slide? So in that case, let's proceed further. Now, let's copy the example here again. So first of all, what I do is I draw a table containing 3 columns. First number goes into the first cell at the second column, then followed by 8 at the third column. Now, we introduce the division symbol at the first cell of the first column. And now the next thing we do is to continuously divide 6 and 8 until our final answers for all is 1 using what? Prime numbers. So as you all know, the smallest prime number I can use so far is 2, because you can divide 6 and 8 by 2. But even if it was only one of them that could be used, of course, I could have still used 2 as well, because the rule is that it should not necessarily be a prime number that should divide both 6 and 8, but just a number that should be able to divide at least one of them. You soon understand why we are going in this direction. So, introducing the number 2, dividing 6 by 2, you come up with the answer 3. And dividing 8 by 2, you come up with the answer 4. Now, let's look for our second prime number to divide again. You do realize that we can divide 4 by 2. So, I'll introduce the 2 again. Do not worry, because the rule is simple. One of the numbers, at least one of the numbers, should be divisible by the chosen prime number. So now, 3 divided by 2 actually will give us a remainder. So let's just write the 3 there like that. And of course, 4 divided by 2 gives us 2. And again, for the last time, you realize that at least we can divide this particular number here, 2, by 2 again. So now doing so, dividing 3 again by 2, let's just write the 3 there like that, since there will be a remainder of 1. Alright. Then, dividing the 2 there by 2, we get the answer 1. Now, finally, we can now move to the next number, which is obviously 3. So, dividing the number 3, dividing the number here, 3, dividing the number 3 by the next prime number, which is 3, you end up getting the answer 1 here. Now, for the next number, which is this very one here, since we cannot divide it by 3 without a remainder, alright, what we simply do is that we write the 1 there like that. Our objective has been achieved since our final answers are now 1, 1. So the LCM of 6 and 8 is simply gotten by multiplying the numbers we used in dividing until the final answers 1, 1 were reached. So in this case, our LCM is simply going to be equal to 2 times 2 times 2 times 3. And that gives us the answer 24. Okay, let's move to the next item. Example. Now, can you find the LCM of 120, 150, and 180? And of course, I can see that some of you, of course, will obviously be able to pull through this. But let's see if we can deal with it. So now, first of all, introducing our table and writing our numbers as shown on the screen. Okay, 120 here, 150 here, and 180 here. All right, and then introducing our division sign. Now, you do realize that at least we can use 2 to divide at least one of them. So, 120 divided by 2 gives us 60. 150 divided by 2 gives us 75. 180 divided by 2 gives us 90. Alright? Now you see that we can use the number 2 again, since it can at least divide 60 or even 90. Alright? Even though we cannot use 2 to divide 75, without a remainder, we simply continue, because at least our number 2 can divide 60 and 90. All right? Because the rule is simple. The number 2 or the number you are choosing should be able to divide at least one of them. So that means we can simply use 2 again. So now, 60 divided by 2 gives us 30. And 75 divided by 2, of course, we'll get a remainder. So we simply put the 75 there like that. Now, 90 divided by 2 gives us the answer 45. Okay? Now, you do realize that we can use the number 2 again, since it can divide at least 30. All right? So, 30 divided by 2 gives us 15. 75 divided by 2, there will be a remainder. So, let's just write the 75 there like that. 45 divided by 2 will also give us a remainder. So, we write the 45 there like that. Now, it's obvious that we can't use 2 to divide again, since they are all odd numbers. But there's something I'm seeing here. We can use the next prime number, which is 3, to divide them. All right, so I introduce the number 3. 15 divided by 3 gives us 5. 75 divided by 3 gives us 25. 45 divided by 3 gives us 15. All right. Now, you do realize that I can use the number 3 again, since it can divide 15. Okay, 15 right here, we can use it to still divide. We can still divide 15 by 3. So, I'll repeat the 3 division again. So, 5 divided by 3, since there will be a remainder, I'll write the 5 there like that. 25 divided by 3, there will be a remainder, so I'll write the 25 there like that. Now, 15 divided by 3 gives us the number 5. Now, you do realize that I can't use the number 3 again. But the next prime number 5 can be used to divide. So, I introduce the number 5. 5 divided by 5 gives us 1. 25 divided by 5 gives us 5. And now, this 5 divided by 5 gives us 1. Now, we'll do our last division. All right, we can use the 5 again. All right, so 1 divided by 5, since will be a remainder, just write the 1 there like that. All right, write the 1 there like that. Now, 5 divided by 5 gives us 1, and 1 divided by 5, of course, there will be a remainder, so we just simply write the number there 1 like that. Okay, so now, what is our LCM now? The LCM is simply gotten by multiplying the divisors we used. All right, so we have to multiply 2 by 2 by 2 by 3 by 3 by 5 and by 5. All right, and that is simply going to give us our LCM. So the LCM is simply going to be given as shown on the screen. So LCM is simply equal to 2 times 2 times 2 times 3 times 3 times 5 times 5. And the answer is going to be, obviously, 1,800. I don't think this would have been possible for you to get using the listing method or listing the multiples before looking for the multiples of the least common multiple. So this method is highly encouraged, of course, when you are dealing with very big numbers. All right, it can help you find the LCM of very large numbers easily. All right, so take note of it critically, because you might need it in your examination hall. Okay, let's move to the next item. Now, let's look at applications of the LCM. For instance, look at the problem on the screen. Luke exercises every 12 days and John every 8 days. Luke and John both exercise today. After how many days will they exercise together? All right, we saw a similar question like this in the beginning. All right, we'll subsequently solve that particular question, but let's look at this question first. All right, so solution. All right, so we just quickly introduce the question on that particular side of the left hand side of our screen, and of course proceed to the solution. So once again, this type of question here demands the use of the LCM. What is it that you always use to know that it involves the use of the LCM or the HCF? It's simple. You realize that this particular question demands compounding the days. All right. Once it involves compounding, it suggests multiples, and subsequently, once we're looking for a common meeting point, then you should be thinking of using the LCM. All right. So let's look at the solution to the problem. Now, solution. The multiples of 12 are simply 12, 24, 36, 48, 60, 72, and so on and so forth. And the multiples of 8 are simply 8, 16, 24, 32, 40, 48, 56, and so on and so forth. Now, looking at the list on the screen, or the multiples of the individual numbers on the screen, which number do you think is common? All right, what's the smallest number common in the set of multiples of the two numbers? Now, you do realize that the answer is simply 24. So how do we conclude our answer? Therefore, both John and Luke will exercise together again after 24 days have passed. Let's look at this problem. A bell rings every 18 minutes and another every 24 minutes and the last every 30 minutes. At 5 o'clock p.m., the two bells rang simultaneously. At what time will the bells ring again at the same time? Okay. So again, once you realize that this question involves compounding in minutes or repetitions of minutes or intervals, then it suggests the use of multiples and subsequently using the least common multiple idea. Now let's come to the solution. Now we draw our table again. Now, since we are dealing with 18 and 24, I just prefer to use this table. All right, don't worry, you can use any other method. You can use the listing method if you so prefer. Okay, so I'll introduce 18, 24, and of course 30 as shown in the screen. Then we divide them. We'll bring in our division symbol. Next, we look for the first prime number we can use to divide at least one of them. And I think the obvious one we can use is simply 2. Now, 18 divided by 2 gives you 9. 24 divided by 2 gives you 12. 30 divided by 2 gives you 15. Now, you do realize that I can use 2 again. Now, in that case, going further, 9 divided by 2, there will be a remainder. So let's just write the 9 there like that. 12 divided by 2 gives us 6. 15 divided by 2, of course, will be a remainder. So we'll just write the 15 there like that. Now, you see that we can still use 2 to divide because of the number 6, as you can see on the screen. So, going forward, 9 divided by 2, of course, will be a remainder. So we just write the 9 there like that. 6 divided by 2 gives us 3. And 15 divided by 2 gives us 15. Next, you do realize that we cannot use the number 2 again since none of the numbers there are perfectly divisible by 2. The next obvious prime number we can use is the number 3. Since the number 3 can divide at least 1. So, we bring it in. 9 divided by 3 gives us 3. 3 divided by 3 gives us 1. 15 divided by 3 gives us, of course, 5. Now, you do realize that we can use the number 3 again due to just this number right here. The 3 right here. So, in that case, dividing again by 3, or 3 divided by 3 gives us the number 1. 1 divided by 3, of course, obviously, there will be a remainder. So, we just write the 1 there. Now, 5 divided by 3 simply gives us, of course, 5 again, since that number 2 also gives us another remainder. Finally, we can use the number 5. So, 1 divided by 5, yes, there will be a remainder. So, just write the 5 there like that, the 1 there like that. 1 divided by 5, of course, gives us 0 remainder 1. So, due to that, we just write the 1 there like that as well. Now, 5 divided by 5 gives us 1. Now, simply, our LCM is simply going to be gotten by, again, multiplying the set of prime numbers we use to divide. All right? So, our LCM is simply going to be equal to 2 times 2 times 2 times 3 times 3 times 5. All right? And that gives us the number 360. Remember, 360 what? Minutes. All right? So, to know the time they'll ring again, we have to change this very number to, of course, hours. and add it to the time to see when the bells ring again. Now that's they ring together in the next 30 minutes. So let's convert the 30 minutes into hours first. Now we simply do this by dividing the 360 by 60, since of course 60 minutes gives us 1 hour. So and the answer we get will be 6 hours. Now adding the 5 o'clock p.m. or adding 6 on top of 5 o'clock p.m. leads us to 11 o'clock p.m. So we just simply conclude that they ring together at 11 o'clock p.m. I hope this is quite understandable. All right. Take this particular lesson serious, since you'll be meeting more of this most likely in your examinations. Now let's look at one last application problem so we can bring this video to a close. Now, what is the smallest number divisible by 3, 5, and 6? All right, as an example. Okay, so I think these numbers are pretty much small, so we just simply use the multiple or the listing method to look for the LCM. All right, remember I told you that the LCM is also the smallest number divisible by a given set of numbers. So in other words, the LCM of 3, 5, and 6 will simply be the smallest number that is divisible by 3, 5, and 6. In other words, the smallest number that 3, 5, and 6 can divide all together. All right, so looking at the solution, the multiples of 3 include 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and so on and so forth. The multiples of 5 include 5, 10, 15, 20, 25, 30, 35, and so on and so forth. All right. And the multiples of 6 include 6, 12, 18, 24, 30, 36, and so on and so forth. Now, look at the individual sets. What is the smallest number that appears in all the 3 sets? You are very much right. The answer is simply 30. All right, so we simply say that therefore the smallest number divisible by 3, 5, and 6 is 30. Thank you so much for your time, and make sure you hit on the subscribe button and click on the notification bell so that once more videos are posted, you easily be notified. Okay, take this very serious because I'll be uploading more videos like this on this very platform. Thank you for your time, and may the good Lord bless you and see you through in the coming examinations.